Dr. Arif Anjum sir, IQAC coordinator Dr. Shakib Ahmed, estimated guest Honorable Dr. Kailash Mdoke, distinguished faculties, research scholars, and dear students. A very warm welcome to all of you. It's an honor to address such an estimated gathering today's national webinar on fundamentals of electrochemistry and see its impact on energy and environment. The electrochemistry is a dynamic field that continues to evolve and shape our future. I am Sauda Sadaf from Chemistry Department of MGV's Arts, Commerce and Science College, Malegaon City. I am honored to be your host for today. We are truly delighted to have such a distinguished guest, researchers, and enthusiastic influence with us. Throughout this session, we will explore advancement, real-world application, and groundbreaking innovation that contributes to energy solution, environment, and sustainability. I am certain that today's discussion will provide valuable insights and inspire new perspectives to officially begin the today's session. Now, I invite our IQSC coordinator, Dr. Shakib Ahmed, to deliver the welcome address and set the stage of this webinar. Dr. Shakib Ahmed, sir, please.
Good morning, everyone. On behalf of MGV's Arts, Commerce and Science College, Malegaon City, I, Dr. Shakib Ahmed, the IQC coordinator of the college, welcome all the participants, especially our today's resource person, Dr. Kailash M. Doke, sir. He is a professor of Department of Chemistry at Abda Inamdar Senior College, Pune. I welcome all the participants and I hope that the objectives of today's webinar will definitely achieve and we will explore fundamentals of electrochemistry definitely. So once again, I congratulate Department of Chemistry for organizing such a wonderful webinar and request all the participants to pay attention on the lectures and get benefited from this. Thank you very much for inviting me for this welcome note. Thank you.
Thank you, sir, for your warm and inspiring words. To provide a clear understanding of the objectives and significance of today's webinar, now uh, I would like to invite Professor Mudassir Rahmani, Head of Chemistry Department, to share in his insights. Professor Mudassir Rahmani, sir, please proceed with the aims and objectives.
Thank you, ma'am. I am Professor Rahmani Mudassir from Head of the Department of Chemistry from City College. The aim of this webinar is to provide a comprehensive understanding of fundamental principle of electrochemistry, which is crucial for understanding various electrochemical processes and their applications. The objectives of this webinar is to equip participants with a solid foundation in electrochemistry, enabling them to appreciate its significance in various fields such as energy storage, corrosion, and analytical chemistry. Especially, this webinar is aims to clarify the basic concepts of electrochemistry, including electrochemical cells, electrodes, and electrolytes. Explain the principle of electrochemical reactions, including oxidation, reduction, reaction, and electrode kinetics, and discuss the application of electrochemistry in various fields. By the end of this webinar, participants will have clear understanding of the fundamentals of electrochemistry and be able to apply this knowledge in their respective fields. Thank you, ma'am. Over to you.
Thank you so much, sir, for your valuable perspectives. Now, I would like to invite Professor Atra from the Assistant Professor of Chemistry Department to introduce estimated guest speaker for today's webinar. Professor Atra, ma'am, please take over.
everyone. I am honored to be here today among such esteemed scholars and researchers. My name is Professor Atra and I am working as an assistant professor in the chemistry department at City College. It is my absolute honor to introduce our esteemed speaker for today's national webinar on fundamentals of electrochemistry. We are privileged to have with us Dr. Kailas Mahadev Doke, a distinguished professor in the Department of Chemistry at Abida Inamdar Senior College, Pune. Dr. Doke holds a PhD in chemistry from SP Pune University and has over 30 years of teaching experience specializing in physical chemistry, thermodynamics, kinetics, and quantum mechanics. His contributions to the field of chemistry are remarkable. He has published 13 research papers in high impact Scopus Index journals, including the Journal of Environmental Chemical Engineering and the Arabian Journal of Chemistry, with over 600 citations. Additionally, he has successfully completed research projects on industrial effluent water analysis and quality control of herbal drugs. Dr. Doke is also a prolific author, having co-authored over 25 textbooks for undergraduate and postgraduate chemistry students, including textbook of physical and inorganic chemistry and advanced practical in physical chemistry. His dedication to academia has earned him prestigious awards, including Outstanding Contribution in Reviewing Research Journal 2016, Ideal Teacher Award, Muslim Welfare Education Society in year 2015 and also received Best Teacher Award Abida Inamdar Senior College in 2014. Beyond teaching and research, Dr. Doke has played a vital role in faculty development programs, conferences, and workshops, serving as an external examiner and delivering guest lectures at various academic institutions. We are truly fortunate to have him share his expertise with us today. So, without further ado, let us welcome Dr. Kailas Mahadev Doke.
Okay, thanks to nice introduction. Can you see the screen?
Yes, sir.
Okay, shall I start?
Yes, sir, please.
Okay. Uh, Thanks to Mudassar sir and the team of Malegaon City College for inviting me to give the talk on this webinar on the topics fundamentals of electrochemistry. Although you feels that it is a fundamental, but at the end of this talk, I will go to latest applications of electrochemistry also. So today uh, we are talking about the fundamentals of electrochemistry, and many times the electrochemistry is concerned with the different types of cells, electrolytic cells and electrochemical cells. Uh, Basically, the electrochemistry is concerned with the interconversion of chemical energy and electrical energy. So, uh, in the electrolytic cell, electrical energy is converted into chemical energy, or electricity is utilized to bring a chemical reaction in the electrolytic cell. Whereas in electrochemical cells, the chemical energy is converted into electrical energy. The electrolytic cells gives the chemical reaction which is a non-spontaneous, whereas an electrochemical cell where the electricity is generated which is a spontaneous. uh, in every cells there are cathodes and anodes, and many times students and many teachers confuse which should be called as a cathode and which should be called as an anode. Whether it is a positive electrode or negative electrode is called as a cathode or anodes. So there is always confusion. So I will try to remove that confusion, which is to be called as a cathode and anode throughout the talk. Since two types of cells are reversible, electrolytic cells and electrochemical cells, where the electrical energy is converted into chemical energy or chemical energy is converted into electrical energy, it has a lot of applications. Both type of electrochemical cells or electrolytic cells has a lot of applications. In many industrial applications where the electrolytic cell is used, whereas in the day-to-day applications in the cells and batteries where the electrochemical cells is used. The basic ideas of fundamentals of electrochemistry is concerned with the conductor. Ability to carry the current is called as a conductor. Conductors can be two types: ionic conductors and electrical conductors. In the ionic conductors, with the help of migration of ions, the electric currents can conduct. And in electrical conductors, due to migration of electrons, the electricity flows, which is called as a electrical conductors. So electrochemistry is concerned with the both type of conductor, ionic conductor also and electrical conductor also. So just I will explain one by one. In electrolytic cells and electrochemical cells, first I will briefly explain what is a electrolytic cell and what are their applications, what are the fundamentals of electrolytic cells and where it is applied in day-to-day life. From the last 2 3 decades, sorry, last 2 3 centuries, we are using electrolytic cells, which has lot of industrial applications. So, uh, in this electrochemistry, the cell is nothing but the device, which does not means the plants and animal cells. Electrolytic cells and electrochemical cell. To construct the electrolytic cell and electrochemical cell, can you see the slides, students? Can you see the PPT?
Yes, sir.
Okay,
Visible.
okay. So to construct the cell, what are the requirements? If you are performing the research, any kind of research, if you want to do the research in electrochemistry, what should be the minimum requirements for the construction of any type of cell, whether it is a electrolytic cell or electrochemical cell? It should have one vessel, minimum one vessel. Sometimes it requires two vessel also. The vessel can be from the glass or metals or insulators. That vessel can act. In addition to vessels, we need a conducting medium in the vessels, which acts as an ionic conducting medium. I told you before. Then, in addition to that, we need two electrodes, minimum two electrodes to construct a electrolytic cell. And yes, anyone wants to ask some question? Mute your phones or your equipments, whatever the you are using. Both the electrodes should be inert. Why we need a inert electrodes? Because that inert electrode should not react with the conducting medium material. That is the reason that electrodes should be the inert electrodes. And in addition to that, it requires a source of electricity or power supply in electrolytic cell, which we use normally battery or alternating current or direct current is used nowadays for the construction of electrolytic cell. Usually, a battery, there are two terminals. One terminal is negative and another terminal is positive. And in electronic circuit also, you might have seen number of times minus sign and plus sign. The minus sign suggests that this is a electron rich terminal, and plus sign suggests that it is a electron deficient terminal of the battery. So, if we connect the electrodes which is connected to the negative terminal of the battery, which is having electron rich species, and the terminal which is connected, the electrode is connected to the positive terminal, which is electron deficient terminal in the battery. So naturally, due to this connection, one of the electrode out of two inert electrode becomes a negative electrode, and another electrode will becomes a positive electrode. So naturally, the electrode, inert electrode, which is connected to the negative terminal, where the electron coming through the electric wire towards the inert electrode, which is a electron rich species. So this initial inert electrode becomes a negative electrode naturally, and another electrode from where the electron will flow towards the positive terminal of the battery. Naturally, it becomes a positive terminal. So the sign, one electrode should be the negative and another electrode should be the positive. It is a common fundamentals of electrochemistry. So this is to construct any electrolytic cell which has a lot of industrial applications. We need a vessel, conducting medium, two inert electrodes, and source of electricity, either battery or AC or DC, that should be there in the construction of electrolytic cell. Now, I will ask one question. The question is written over here in the uh, what chemical species would be present in a vessel of molten sodium chloride? What is meant by molten sodium chloride? That solid sodium chloride is heated and it is converted into liquid sodium chloride. That sodium chloride is called as a molten sodium chloride. So if we have liquid molten sodium chloride, how many chemical species and what are their names of molten chemical species which is present? Can you guess, student? This question is for student. In a vessel, we have a molten sodium chloride. How many chemical species will be there? And what are the chemical species is present in the vessels of molten sodium chloride? Lecture, this webinar will be two side. It will not be one side, so that I should get the idea whether you will understood this particular topic or not. हिंदी में पूछता हूं, अगर हमने मोल्टन सोडियम क्लोराइड एक बीकर में लिया तो उसमें कौन से केमिकल स्पेसीज रहेंगे? कुछ कैटायन रहेंगे, कुछ एनायन रहेंगे, या सिर्फ NaCl रहेगा? Any answer from student side? Okay, I will give the answer. If it is in the liquid state, sodium chloride is in the liquid state, that Na and chlorine will be separated in the form of ions. So which we got two chemical species compulsory, Na plus ion and Cl minus ion. No any another chemical species in the molten sodium chloride, because we converted solid sodium chloride into liquid sodium chloride. Once it forms in the liquid state, naturally it will dissociates, because sodium chloride is a electrolyte, strong electrolytes. It dissociates, not required aqueous condition. Naturally, it converts into the Na plus ion and Cl minus ion. So, this two chemical species is present in the vessels of molten sodium chloride. And when we dip two inert electrode into this molten sodium chloride, we will observe what kind of reaction takes place in this electrolytic cell. So let us examine the electrolytic cell consists of conducting medium as a molten sodium chloride in the liquid state. This is the slides. Can you see the slides, student?
Yes, sir.
So we can observe the reaction. We can observe the reaction. Vessel is there, two inert electrode is there, and the electrode which is connected to the negative terminal, which acts as a negative electrode. The electrode which is connected to the positive terminal of the source acts as a positive electrode. And in molten sodium chloride, which consists of Na plus ion also and Cl minus ions also. So we can observe the reaction at the electrodes. You can observe the reaction. Can you see that some reactions are taking place? आप नजर आ रहा है कुछ reactions?
Yes, sir.
जी जी सर।
हाँ, bubbles, कुछ bubbles नजर आ रहे हैं. One electrode के तरफ कुछ bubbles नजर आ रहे हैं. Other electrode के तरफ कुछ collection नजर आ रहा है. Once again I repeat, you can observe the reaction at the electrodes. This is happened in the naturally because we apply the electricity. So one electrode becomes negative electrode, another becomes a positive electrodes. And due to presence of Na plus and Cl minus ion, some reaction takes place on negative electrode and some reaction takes place on positive electrode. So what the reaction takes place on negative electrode and positive electrodes, we can observe. So what the reaction takes place? You can observe the reaction. हेलो, शायद किसी का माइक्रोफोन ऑफ नहीं है. कुछ बाहर का वर्कशॉप का कुछ आवाज आ रही. Okay. Now you observe that on one electrode the chlorine gas is liberated, and this is a chlorine gas coming in the atmosphere, where the two chlorine ions from the molten sodium chloride on the surface of positive electrode, they combines together and it forms a chlorine gas by the loss of two electrons. So in chemistry, this type of reaction is called as a oxidation reaction. Oxidation is takes place on positive electrode, whereas on the another electrode, negative electrode, Na plus ion migrates towards the negative electrode and it converts into the sodium in the liquid state on this particular electrode. This reaction is called as a reduction reaction. So one side oxidation reaction takes place, another side reduction reaction takes place, and it is due to the migration of sodium ions towards the negative electrode, opposite charge attraction, and migration of Cl minus ions towards the positive electrode, opposite charge attraction. Due to this ionic mobility, ionic conductivity, oxidation and reduction reaction takes place, where there is an excess of electron on the negative electrode. So sodium ion requires the electron to undergo the reduction reaction, whereas that chlorine minus ion consists of extra electron which will converts into the chlorine gas, where the positive electrode, the electron deficient electrode, that chlorine ions loses the electron and it will carry with the uh, positive electrode on the surface of that particular electrode. So chlorine gas escapes out at the positive electrode, and sodium liquid is collected on the surface of molten sodium chloride, since the density of sodium in the liquid state is less than density of molten sodium chloride. So this reaction takes place on the uh, electrolytic cell. Now you can observe at the microscopic level. माइक्रोस्कोपिक लेवल पे आप रिएक्शन ऑब्जर्व कर सकते हैं. हाउ द इलेक्ट्रॉन इज ट्रांसपोर्ट, how Na plus ion is migrated towards negative electrode, how Cl minus ion is migrated towards the positive electrode. Again, you can observe at microscopic level. The electron is migrated towards the electrode foil, and from the negative terminal of the battery towards the electrode, and in opposite side, again you can observe the electron is generated in the oxidation reaction and electron is consumed in the reduction reaction. So cation migrates towards the negative electrode, anion migrates towards the positive electrode. Now I will ask one question. This negative electrode and this positive electrode, such type of electrolytic cell is to be called as a two nomenclature, cathodes and anodes. Can anyone answer this negative electrode is called as a cathode or anode? Can you hear me, student?
Yes, sir.
Yeah,
It's called a anode.
it is called as a
Anode.
anode. Any another answer? Does in electrolytic cell, this electrode is called as an anode? One student or one participant gave the answer that this negative electrode is called as an anode. Everyone is agree or disagree?
Yes, sir. This is correct.
Agree, sir.
Agree. Okay.
Agree,
Now,
sir.
okay. See that in electrolytic cells, sign conventions are different, and in electrochemical cells, sign conventions are different. Why? This negative electrode is called either cathode or anode. Initially, what should be called as a cathode or anode? So those electrode in electrolytic cell where the cation is migrated towards the cation is migrated, and those electrode where the anion is migrated, accordingly their nomenclature comes in electrolytic cell, because cation is migrated towards negative electrode, that electrode should called as a cathode, and the anion is migrated towards the electrode which is positive electrode, which should called as a anode. How to remember in electrolytic cell which is cathode and which is anode? Those electrode towards cathode is migrated, sorry, cation is migrated, those electrode towards cation is migrated, that electrode should called as a cathode, Cc. How you should remember fundamental? Cation is migrated towards cathode, anion is migrated towards anode. A, anion should migrated towards anode, that electrode should be positive electrode, anode should be positive electrode, and cathode should be the negative electrode in electrolytic cell. Your answer is correct, that negative electrode is called as an anode, but it is applicable for electrochemical cell. So sign convention and nomenclature is opposite, since the electrolytic cell reaction and electrochemical cell reactions are exactly opposite. Oxidation and reduction reactions, whatever takes place in electrolytic cell and electrochemical cells are opposite. Therefore, the electrode in electrolytic cell where the cation is migrated towards that electrode should called as a cathode, and the electrode where the anion is migrated, that electrode, anion is negatively charged electrode, and that positive electrode, the anion migrates towards the positive electrode. That electrode should be called as a anode. Is that clear?
Yes, sir.
Okay, this is this way you have to understood whether you have to analyze, you are studying electrolytic cell or electrochemical cell. If it is a electrolytic cell, the electrolytic cell naturally, because of electricity is applied through battery or DC or AC, one electrode acts as a negative electrode and another electrode acts as a positive electrode. So towards negative electrode, if cation is attracted, that electrode should be called as a cathode. Towards positive electrode, anion is attracted, that electrode should be called as a anode. We will go to next slide. This is cathode and anode where oxidation and reduction reaction takes place. Cathode reaction where the reduction reaction takes place, which is negative electrode. Anode reaction where the oxidation reaction takes place, and the net cell reaction, overall cell reaction, is just the electron loss and electron gain is cancelled. So Na plus ion and Cl minus ion produce sodium in the liquid state and chlorine in the gaseous state. So this electrolysis reaction of sodium chloride, molten sodium chloride is carried out, and in industry we can produce sodium metallic in the liquid state, and we can synthesize chlorine gas from the molten sodium chloride by electrolysis reaction in the electrolytic cell. Uh, this reaction is called as a non-spontaneous reaction because this reaction does not occur naturally. Here we have to apply the electricity. So without electricity, we cannot undergo the electrolysis reaction. So therefore, this reaction is called as a non-spontaneous reaction. Now another question: what chemical species would be present in a vessel of aqueous sodium chloride? Now sodium chloride has been changed. Instead of molten sodium chloride, if you took the aqueous sodium chloride, what is aqueous sodium chloride? Sodium chloride solid is dissolved into the water, aqua. So what chemical species is present? It consists of Na plus, because of dissociation. It consists of Cl minus, and in addition to that, if you have pure water, it consists of H2O molecule. So these three chemical species is present in the aqueous sodium chloride. In molten sodium chloride, only Na plus and Cl minus ion is present as a chemical species. In addition to Na plus and Cl minus ion, we have now H2O as a chemical molecules, chemical species in the aqueous sodium chloride. So when we took the aqueous sodium chloride in the conducting medium, whether the reaction will be same or different, that we are going to study in the next slide. Will the half reaction will be the same or different? We can observe here. We took the aqueous NaCl instead of molten NaCl, in which consists of Na plus ion, Cl minus ion, and water. Three chemical species are there. And can you observe the reaction now? Can you see the reaction? Can you
Yes, sir.
visualize the reaction? Are the reactions are same like previous reaction on both the electrode? Can you observe the bubble?
Yes, sir.
Yes, sir.
You
It's
observe you observe the bubble on both the electrode. Yes or no?
Yes, sir.
Yes,
Yes, sir.
yeah. So it means that something is different reaction. One chemical species change the reaction of electrolytic cell. How chemistry becomes a different, how electrochemistry becomes a different. So it needs some fundamental knowledge where the aqueous sodium chloride is there, which consists of Na plus, Cl minus, and H2O as a chemical species, and therefore the observed reaction will be the different than the molten sodium chloride. So we explain. On anode, that is a positive electrode, negatively charged ion migrates naturally, and chlorine gas is liberated. So same reaction takes place like molten sodium chloride, but on surface of cathode it might be different reaction takes place. If Na plus ion is migrated and sodium is electrolyzed as a sodium liquid, then sodium should be collected in the liquid state in the electrolytic conductor container. But here also we observed that some gas is liberated. So it might have some different reaction. So what the different reaction takes place, I will tell you. Possibilities in the electrolytic cell, possible cathode half cell, two possible reduction reaction. Na plus can be reduced to Na in the liquid state. That is one possibility. And third chemical species, water is there. So water can be reduced by gain of electron, and hydrogen is produced and OH minus ion is produced. After a few minutes, I will explain why this two possible reaction. So water का भी reduction होता है. Na plus ion का reduction होगा. Water is neutral, but it has amphoteric properties. So it acts as acid, it acts as a base. So that water acts as a H3O plus ion also in presence of H plus ion in acidic condition. So उसका भी रिडक्शन हो सकता है. ये दो पॉसिबल रिडक्शन रिएक्शन कैथोड पे होने के चांसेस है. आउट ऑफ दिस टू रिएक्शन, जो रिएक्शन मोल्टन सोडियम क्लोराइड में होता था, यह पॉसिबिलिटी कम है. क्यों कम है आपको एक दो स्लाइड के बाद मैं एक्सप्लेन करूंगा. Whereas in the anode also two possibilities of oxidation reaction takes place. Chlorine can be oxidized or water can be oxidized into oxygen, and uh, that electron will be lost in the oxidation reaction. But here confirm that water is not oxidized and chlorine gas is oxidized. How we know this property, that I will explain after some extra knowledge. You must know that extra knowledge. So overall cell reaction in this previous case, that chlorine and H2O, Na plus is not reacting over here. It gives hydrogen in the gaseous state on cathode and chlorine in the gaseous state on anode. So this is the net cell reaction. On surface of one electrode, this electrode hydrogen gas is liberated, and on surface of positive electrode anode, the chlorine gas is liberated. So here the H2O is more dominant than Na plus ion in the reduction reaction. Chlorine is more dominant than H2O in the oxidation reaction. So minor change in chemistry, chemical species, electrolysis reaction will change. That's why electrochemistry, the fundamental knowledge is very very important. So why Na plus is not reduced and water is not oxidized? Why H2O is reduced and chlorine gas is oxidized? That I will explain after 2-3 slides. Now I will switch over to applications of electrolytic cell in the electroplating of metals. Electroplating of metals. In electroplating industry, we can electroplating silver. We can produce silver spoon just by passing the electricity on cathode. That electron is migrated in the towards the electrode after applying the electricity, and from solution Ag plus ion, silver nitrate ion is taken in the vessel. So silver ion is migrated towards the silver spoon and that metal, where we can do the electroplating, and silver is deposited on the surface of that particular metal. So electroplating industry, the electrolytic cell is used. This I will skip up. We can electrolyze number of series of ions by using coupling a series of different electrolytic cells. We can electrolyte gold also, zinc also, uh, silver also. By applying the same amount of electricity, we utilize one definite quantity of electricity and apply the electricity. We can deposit the silver by copper, silver as well as zinc. That is another applications of electrolytic cells, where the on positive electrode, on anode, the metals get deposited. That phenomenon is called as a electroplating in industry. Another application, these are the reaction where the gold is converted, gold ion is converted into gold solid, zinc ion is converted into zinc solid, silver ion is converted into silver solid from the electrolytic solution or conducting material. This is another application of electrolytic cell, extraction of aluminum from aluminum ore. You might have studied in inorganic chemistry, where we can prepare the aluminum oxide solution and we can use series of electrolytic cell or electrodes, and where the oxidation and reduction reaction takes place by applying the electricity between positive terminal and negative terminal, and we can get by electrolysis reaction pure aluminum in the liquid state. By cooling, that liquid aluminum will converted into the aluminum solids. So this is another applications of electrolytic cell, where we can use graphite electrode as an anode, and particularly carbon lines vessel as acts as a cathode. So we can synthesize number of metals. This is a cathode reaction where the reduction reaction takes place, anode reaction where the oxidation reaction takes place, and on the surface of cathode or on the solution, we can connect the aluminum metal like sodium metal. So we can use in the extraction process. Uh, Second part is a electrochemical cell. In electrochemical cell, where the chemical energy is converted into electrical energy. And nowadays, this electrochemical cell is a hot topic in the applications of generation of electricity. We can synthesize lithium cell or sodium cell or any batteries by combination of cells. So electrochemical cell, where the electrical energy is produced by spontaneous chemical reaction. So cell construction, I told you, required minimum one vessel or two vessel. So this is a construction of Daniel cell, where the Daniel is constructed the such type of cell, where copper rod is dipped in the copper sulfate solution, zinc rod is dipped in the zinc sulfate solution, and here the electricity is not applied, battery is not applied in the circuit, where the bulb is there or ammeter is there. We can measure the how much electricity is generated by a spontaneous oxidation and reduction reaction. When we dip copper rod in copper sulfate solution, zinc rod in zinc sulfate solution, naturally one electrode where oxidation reaction takes place, and in on another electrode reduction reaction takes place. To connect the two half cell, we use a salt bridge. So UG students knows what is meant by salt bridge and what are the functions of salt bridge. That I'm not going to explain in detail because we have time limits. I want to show lot of applications related to such type of electrochemical cell. So once we dip zinc rod in zinc sulfate, copper rod in copper sulfate, and when we connect it to the bulb, the electricity is generated, bulb will glow. How a reaction takes place? You can observe the reaction at microscopic level. एक मिनट में आपको एक 10 सेकंड में पता चलेगा। इलेक्ट्रोड जो पहले था कॉपर का, उसका साइज शेप चेंज हो गया। जिंक का इलेक्ट्रोड था, उसका साइज शेप चेंज हो गया। So some reaction takes place on zinc half cell, some reaction takes place on copper half cell. So here the oxidation and reduction reaction takes place. So what happens on each electrode? You can observe On zinc electrodes, zincs get dissolved or erode, and on copper electrode, copper is played out or deposited on surface of electrode. So copper electrode का size बढ़ गया, zinc electrode का size कम हो गया naturally, just by dipping zinc in zinc sulfate solution and copper in copper sulfate solution. We are not applying external agency. So what the reaction takes place in both the cell. Now the sign conventions are opposite. Later on I will explain that parts. That copper 2 plus ion is converted into copper solid. The copper 2 plus ion from solution, copper 2 plus ion from solution gains 2 electron on the surface of copper metal, which is in the solid state, because metal is made from the electron, which consists of free electron. So they can easily donate the electron to copper 2 plus ion from solution. So when copper 2 plus ion contacts with the copper solid, it 2 electron is gained by copper 2 plus ion, and it will converts into the copper solid, which will be deposited on surface of copper rod. That reaction is called as a reduction reaction. Whereas in another electrode, the zinc rod consists of zinc solid. It has a natural tendency when it contacts with its aqueous solution containing Zn2 plus ion, it has a tendency to pass into the solution in the aqueous state naturally. So zinc will pass into the Zn2 plus ion in the aqueous solution, leaving behind 2 electrons. Leaving behind 2 electrons. So zinc electrode के पास extra electron रहेंगे. That extra electron ये electrode के ऊपर आएंगे, तो ये electrode के ऊपर negative charge आएगा. Here इलेक्ट्रोड के कॉपर 2 प्लस आयन 2 इलेक्ट्रॉन्स कॉपर 2 प्लस आयन ने गेन किए, तो दिस कॉपर बिकम्स अ इलेक्ट्रॉन डेफिशिएंट स्पेसिस, एंड इलेक्ट्रॉन डेफिशिएंट स्पेसिस normally it is denoted by positive charge. So naturally one electrode acts as a negative electrode and another electrode acts as a positive electrode, where the negative electrode, now it is called as a anode, where the oxidation reaction takes place, and positive electrode, which is called as a cathode in electrochemical cell, which is exactly opposite sign convention of electrochemical cell, where we call negative electrode as a cathode and positive electrode as a anode. But in electrochemical cell, the positive electrode should called as a cathode, but because the reactions are reverse, and negative electrode should called as a anode. This way you have to remember which electrode is to be called as a cathode and which electrode has to be called as a anode. So this reaction takes place naturally when we dip zinc rod in a zinc sulfate solution and copper rod in the copper sulfate solution. This cell, electrochemical cell, generate the electricity, and this cell was designed by Daniel. So to honor the Daniel, this electrochemical cell, which we call it as a Daniel cell. So it is a very fundamental uh, electrochemical cell, that one electrode acts as a positive electrode and one electrode acts as a negative electrode, because naturally one electrode acts as a positive and one acts as a negative electrode. So electron will migrate from negative electrode from zinc solution, zinc rod, towards the terminal of the bulb. This is a negative terminal and this is a positive terminal, whereas the extra electron will transport through the towards the positive electrode. इसको electron की जरूरत है, ये electron produce कर रहा है, and whenever there is a mobility of electrons, the electricity is generated, which is called as a electrochemical cell. उसका रीजन मैंने ऑलरेडी बताया. Now replace the light bulb with volt meter. बल्ब के जगह अगर वोल्ट मीटर हम कनेक्ट करेंगे और जिंक रॉड जिंक सल्फेट 1 मोलर जिंक सल्फेट में डीप करेंगे और कॉपर रॉड 1 मोलर कॉपर सल्फेट में डीप करेंगे, तो हमको इलेक्ट्रिसिटी मिलेंगी, ईएमएफ प्रोड्यूस होगा, एंड हुज वैल्यू इज अ स्टैंडर्ड. This is called as a standard electrochemical cell, standard Daniel cell. If the measurement is at 25 degrees Celsius, then this potential is called as a standard potential, which gives EMF 1.1 volts in the Daniel cell. If we change the concentration from 1 molar to 0.1 molar, this concentration from 1 molar to 0.1 molar, then the electricity or EMF produced will be the different than 1.1 volts, which is not called as a standard electrochemical cell, but this cell is called as a standard electrochemical cell when we took the concentration of electrolytic solution is a 1 molar 1 molar. So this construction and working of Daniel cell, I will not explain in detail. This that undergraduate students, 12 standard students, any pass out students this kind of reaction, and this is a net cell reaction where the zinc undergo oxidation reaction, where the copper undergo the reduction reaction, and this reaction is a spontaneous reaction where the electricity is generated, electric current is produced. This is at microscopic level. On the surface of zinc rod, these are the zinc atom, natural tendency to pass into the solution leaving behind the electron. So इलेक्ट्रॉन ऊपर चले जाएंगे तो ये इलेक्ट्रोड नेगेटिव बनेगा. Whereas copper 2 plus ion from solution contacts with the copper metal, and 2 electrons from the copper metal gains by the copper ion from solution, it will converts into the copper solids, and oxidation and reduction reaction takes place where we can measure the on voltmeter how much EMF or electricity is produced. Another concept I want to explain is about the measurements of single electrode potential. In the previous slide, we see that we measure the EMF, and this EMF is the potential difference between cathode and anode, or difference between higher oxidation potential minus lower oxidation potential, or oxidation potential plus reduction potential. That gives the total EMF of cell. अगर आपको एक ही इलेक्ट्रोड का ईएमएफ मेजर करना है, आइदर जिंक इलेक्ट्रोड और कॉपर इलेक्ट्रोड, तो एब्सोल्यूट मेजरमेंट इज नॉट पॉसिबल फॉर सिंगल इलेक्ट्रोड. वन इलेक्ट्रोड should be the standard electrode, and another electrode should be the indicator electrode whose potential has to be measured. So standard electrode normally we use is a standard hydrogen electrode as a primary reference electrode, where the conditions should be the standard in the standard electrode. It should be maintained as a standard condition. Whereas in the indicator electrode, we can use another electrode. So standard hydrogen electrode acts as a primary reference electrode or standard electrode to measure the EMF of single electrode potential. But it has a limitation, lot of limitation. We cannot construct the standard hydrogen electrode in our common laboratory, because to maintain the temperature of that electrode system 25 degrees Celsius, solution concentration 1 molar, and atmospheric pressure of hydrogen gas is a 1 atmosphere, is a very difficult to maintain in any undergraduate postgraduate laboratories. So we use normally, instead of standard hydrogen electrode, primary reference electrode as a secondary reference electrode in the laboratory as a calomel electrode. But if we use a standard hydrogen electrode as a measurements of absolute one electrode potential, then for example, if you want to measure the how much potential difference is generated by copper electrode, we have to couple that copper electrode to the standard hydrogen electrode, where the standard hydrogen electrode potential, standard potential is very close to zero, slight positive potential, but we consider it as a 0 volts. So when we connect copper electrode whose potential has to be measured, it has to be connected with the standard hydrogen electrode, and we observe that how much potential is generated. It is because of copper electrode plus standard hydrogen electrode potential, and I told you that the standard hydrogen electrode potential is 0. So whatever the potential observed on the electrochemical cell, it is because of only the copper electrode, because another electrode whose potential is a 0 for the standard hydrogen electrode. So this way we can measure the single electrode potential by coupling the electrode whose potential has to be measured with the standard hydrogen electrode whose potential is accurately known. So what are the reactions that I will skip up? because of time consent. Similarly, uh, we can measure the how much potential is generated by zinc electrode. So zinc electrode should be coupled with the standard hydrogen electrode, and after coupling, we got the EMF is a 0.76 volts. This potential is because of only the uh, zinc electrode, because the standard hydrogen electrode standard potential is equal to 0. So 0 plus 0.76 will be 0.76, and it is because of oxidation reaction of zinc electrodes. This is about the basic electrochemical cell. Basic electrochemical cell. I will switch over to some applied electrochemical cell. Uh, Sir, it is 11:55 almost. Should I continue for 5-10 minutes?
Yes, sir. Please continue.
Okay, okay. So this is a construction of secondary reference electrode, which is called as a saturated calomel electrode, that I'm not going to explain in detail. Now, application parts of electrochemical cell. These are the some elements from the periodic table: chlorine, ozone, thiosulfate, H2O2, MnO4 minus, lead oxide, chlorine, dichromate, manganese oxide, bromine, nitrate, silver, Fe2 plus, then copper 2 plus, जो डैनियल सेल में है, सल्फेट आयन, स्टैनस, स्टैनिक, सल्फर, H plus ion, lead, SN4 plus. All these are the elements from the periodic table, and from these elements we can prepare the electrodes, single electrodes. So these are the standard reduction potential of this particular reaction, this second reaction, third reaction, fourth reaction, fifth reaction, and so on. So how to construct the electrochemical cell? How scientists construct the electrochemical cell? How Daniel cell construct the electrochemical cell? These single electrode potential of all the electrodes from which we can synthesize the electrode from periodic table, all the elements. These are the elements from which we can prepare the electrodes in the laboratory. They are arranged by decreasing their standard reduction potential. ये फर्स्ट जो रिएक्शन है, रिडक्शन रिएक्शन, from fluorine gas we can synthesize the electrode. So whose reduction potential, standard reduction potential, is plus 2.866. This potential goes on decreasing, reduction potential goes on decreasing from top to bottom. It is continued in the right hand side, it is still goes on decreasing up to lithium, whose reduction potential is a minus 3.040. Last one is a lithium. So if you carry electrode measurements, standard reduction potential measurements, from which we can prepare the electrode. I told you in the previous two slides how we measure the electrode potential in the laboratory. That another electrode should be the reference electrode, primary reference electrode or secondary reference electrode. So this way we at standard condition we can measure the electrode potential, and by coupling these two electrodes we can synthesize, we can construct the electrochemical cell. What the Daniel did? Daniel constructed by coupling the copper electrode, whose reduction potential is plus 0.340, with the zinc electrode, whose reduction potential is a minus 0.763. By coupling these two electrodes, Daniel construct the electrochemical cell, which is called as a Daniel cell, and whose potential, whose cell potential is a summation of 0.340 plus 0.763. Reduction plus reduction, sorry, reduction minus reduction, reduction plus oxidation. These minus reduction potential means plus oxidation potential. The sign conventions are opposite. And at the center, this is a hydrogen electrode in the electrochemical cell, where the electrode potential is a 0. सो हाइड्रोजन इलेक्ट्रोड के ऊपर जितने भी इलेक्ट्रोड है उससे हम रिडक्शन इलेक्ट्रोड बना सकते हैं मोर प्रोबेबली, एंड हाइड्रोजन इलेक्ट्रोड के नीचे वाले जो इलेक्ट्रोड है जिसका रिडक्शन पोटेंशियल निगेटिव है लेकिन ऑक्सीडेशन पोटेंशियल पॉजिटिव है. So by coupling these electrodes with these electrodes, we got the electrochemical cell, and all the electrochemical cell, constructed electrochemical cell, which produces the electricity. In electrochemical cell, the electricity should be produced. So, I'm going to explain one important application, something about the lithium ion battery. Lithium ion battery. Nowadays, in all electrical vehicles, the battery is there. In the battery, there are number of cell, and by using number of cell, the battery is produced, and the battery is made from the lithium ion. So that's why it is called as a lithium ion batteries. And if you see that from the periodic table, the most electropositive metal, this lithium is an alkali metal which has a highest oxidation potential, lowest reduction potential. Minus 3.040 is the lowest reduction potential because this lithium is a most electropositive. So lithium has more tendency of oxidation than reduction. So whatever the battery or cell is produced from lithium, when it couples with another electrodes, any of the electrodes from higher reduction potential electrode, which gives a maximum electricity, the electricity density will be more. So that's why in the research nowadays, lithium ion is used in the construction of batteries. Since this is the most electropositive alkali metals from the chemical elements. But the cost is more, the source is a less. So therefore, nowadays the research is going on, and sodium ion battery is now becoming a more popular than lithium ion battery since the cost of lithium ion battery is more. So this is about the dry cell, old cell. Everyone knows about the dry cell. I will skip up this reactions. This is a battery. What is the difference between battery and cell? The battery is made up of number of cell to generate the more electricity because cell generates small quantity of electricity. When we couple 2 cell, 3 cell, 4 cell, 10 cell together, we will get the more electricity. So that is called as a battery. That is the difference between batteries and cell. So lead storage battery we use in the car for the storage of electricity. To start the battery, to start the car, we use a lead storage battery. Their cathodes and anodes where oxidation and reduction reaction takes place. The lead is one of the major component in the lead storage battery. That's why it is called as a lead storage battery. There are fuel cells also. We need a continuous fuel for generation of electricity. So fuel cell is also electrochemical cell, but it requires continuous supply of reactant. हाइड्रोजन एंड ऑक्सीजन से हम फ्यूल सेल बना सकते. सो यू आर फैमिलियर विद द हाइड्रोजन कार वेयर द फ्यूल सेल इज यूज्ड एज अ हाइड्रोजन एज अ फ्यूल. So the whatever the cell or battery which is present in the hydrogen fuel consists of cathodes and anodes as usual, but in addition to that there is a one transport medium that hydrogen ion can transport along with the electron transport in the fuel cell. That system is required. So this is a cross section of hydrogen fuel cell, where the oxidation of hydrogen gas takes place. So it need a continuous supply of hydrogen tank. Air is free in the atmosphere, so oxygen is free, but we need to have a hydrogen fuel. And one side where the anode, where the compulsory oxidation reaction takes place, there is a continuously hydrogen gas passes from one side of the compartment in the hydrogen fuel cell, and at the center there is a proton exchange membrane which exchange proton from one compartment, one half cell to another half cell, where the oxygen is there. That proton reacts with the oxygen. By gain of electron, it will converts into the water. So this overall reaction takes place in the fuel cell. Hydrogen from fuel, oxygen from fuel or atmosphere, it will converts into the water in the hydrogen fuel, where oxidation and reduction reaction takes place. We can generate the electricity. You can see at microscopic level, from one side hydrogen gas H2 molecule is coming in the anode compartment, where the oxidation reaction takes place. Electron is flowing through external circuit. The electron is flowing through external circuit, and hydrogen ion passes from that anode compartment to cathode compartment through the membrane. This membrane is made from special material which is called as a proton exchange membrane, and that hydrogen ion reacts with oxygen gas coming from the air, which undergo the reduction reaction, and the electron is transported from anode to cathode, where the ions is migrated, H plus ion is migrated from one compartment to another compartment, and electron will flow from the negative electrode to the positive electrode, anode to cathode through external circuit, where the electricity is generated in the hydrogen fuel cell. So this nowadays hydrogen fuel car is also coming. In 2014, Toyota begins with the Toyota Miria, world first fuel cell vehicle. Nowadays, Hyundai also launched the Nexa car, hydrogen fuel car, where the electricity is generated in the hydrogen fuel cell as an electrochemical cell. Lithium ion batteries has a lot of applications compared to hydrogen fuel cell. Uh, First lithium ion battery was constructed in 1970 by using titanium sulfide as a cathode and lithium metal as a anode. In 1980, another scientist construct the lithium ion battery by replacing titanium sulfide with the lithium cobalt oxide, and another electrode as a same lithium metal as an anode by oxidation reduction reaction. In 1985, another scientist, one person, modify, and he used a practical application of lithium ion battery by replacing lithium metal as an anode with the graphite lithium as an anode, and together the discovery start in 1970, 1980, 1985, and in 2019 these three person got the Nobel Prize for the lithium ion battery, for the construction of lithium ion battery. And nowadays smartphone whose cost is greater than 1 lakh, laptops, electric vehicles, renewable energy storage, we use a lithium ion batteries as a source of electricity. So what is a lithium ion batteries? This cell, one side there is a lithium metal oxide which acts as a cathode, another side it is a graphite mixed with the lithium, and at the center there is a separator, porous separator, which can transport lithium ion from one compartment to another compartments uh, on both sides, where the charging and discharging takes place. When we carry the discharging, means when we are using a mobile in which lithium ion battery is there, what the reaction takes place? On anode, oxidation reaction takes place. That lithium carbide is converted into lithium ion by loss of electron, and where the cathode, the cobalt oxide and lithium is converted into lithium cobalt oxide by gain of electrons. So one side there is a loss of electron, one side there is a gain of electron. Electron will transport from higher density electron side to lower density electron side, that is from anode to cathode in electrochemical cell, and through this porous membrane the lithium ion is generated from this compartment, transport from anode compartment to cathode compartments when it is a discharging. So अगर हम lithium बैटरी यूज कर रहे हैं, when it is in use, मोबाइल हम यूज कर रहे हैं तो डिस्चार्जिंग होगा. अगर हम चार्जिंग को लगाएंगे, चार्जिंग को, तो एग्जैक्टली अपोजिट रिएक्शन होता है. व्हेन वी यूज एज अ पावर सोर्स, हम एसी को कनेक्ट करेंगे, चार्जर लगाएंगे तो क्या रिएक्शन होती? एग्जैक्टली अपोजिट रिएक्शन होती, वेयर द इलेक्ट्रॉन विल ट्रांसपोर्ट फ्रॉम कैथोड टू एनोड. On cathode, oxidation reaction takes place. On anode, reduction reaction takes place, and the electron will migrate in opposite direction from cathode to anode when the charging is carried out, and lithium ion, generated lithium ion, again migrates it towards from the cathode compartment to anode compartment. So overall concentration of lithium ion battery for longer period of time kept as a constant. That is a purpose of construction of lithium ion battery. And nowadays lithium ion batteries are very famous. Only limitation is that the cost of construction is very high, because price of lithium ion battery is high, since the source of lithium in our universe is a very small. In only few countries the lithium source is there, which is very costly. So people are further doing some research, and they are replacing now lithium ion battery as a sodium ion battery, which is a energy efficient, which is a low cost. Sodium is a easily abundant in our universe. In China, this company Catalyst announced the first commercial sodium ion battery for energy storage as well as electric vehicles. And many of the electric vehicles now converted from lithium ion batteries to sodium ion battery. Only there are certain limitations by replacing lithium ion batteries with the sodium ion batteries. So this is a construction of sodium ion batteries similar to lithium ion batteries. The electrolytes is a replace, that lithium is replaced by sodium ion. That is the only difference. Rest of the chemistry is same, chemical reaction is the same. So ions get transports when it is a charging from one compartment to another compartment. Electron will flow through external electric circuit from anode to cathode or cathode to anode. So when there is a charging, the electron will transport from cathode to anode. Where is a discharging, the electron will flow in the opposite direction. And overall concentration of electrolytic solution will remains constant for longer time. So cathode is made from sodium iron phosphate in the sodium ion batteries, and anode is made from sodium carbide like lithium carbide in the lithium ion batteries. So only electrolyte concentration is different, and lithium is replaced by Na plus ion, and almost the reaction is same, but it has a certain limitation. The last slide is this one. Difference between sodium ion batteries and lithium ion batteries. In the sodium ion batteries, ionic charge carrier is a sodium ion, whereas in the lithium ion batteries, ionic charge carrier is a lithium ion. Elemental abundance in our universe is more in sodium, cheaper, expensive lithium source. Only there is a certain limitation, and people are doing some research that the electron density or energy density of sodium ion battery is less compared to lithium ion battery, whereas the voltage output is also less compared to the lithium ion batteries. That is a limitation of sodium ion batteries over the lithium ion batteries. Life cycle of lithium ion batteries. up to 3000 to 5000 cycle we can do the charging and discharging, but in the sodium ion battery about 2000 cycles, up to 2000 cycles we can use a sodium ion batteries. Charging discharging rate is very faster in lithium ion battery, but slightly slower in the sodium ion batteries. Electrode material, I already told you, the sodium battery is a cheaper, whereas a lithium battery is a expensive. So the sodium ion battery is a more eco-friendly compared to lithium ion battery, because lithium source का mining करना पड़ता है, and which is very expensive as well, not environmental friendly, but the sodium ion is abundant in nature, which is a very environmental friendly. टेम्परेचर स्टेबिलिटी अगर आप देखेंगे तो सोडियम आयन बैटरी इज अ मोर सेफर कंपेयर टू द लिथियम आयन बैटरी. आपने सुना रहेगा न्यूज़पेपर में कि लिथियम आयन बैटरी वाले कार या इलेक्ट्रिक व्हीकल्स फायर, इट टेक्स फायर बिकॉज टेम्परेचर स्टेबिलिटी अभी प्रॉपरली कंट्रोल नहीं हुआ. अगर ऑर्डिनरी आप लिथियम आयन बैटरी यूज करते हैं तो अच्छा कंपनी का बैटरी यूज करते हैं तो टेम्परेचर स्टेबिलिटी इज देयर. कमर्शियल अवेलेबिलिटी अभी लिमिटेड है सोडियम आयन बैटरी का. लिथियम आयन बैटरी वाइडली ऑल ओवर द वर्ल्ड यूज हो रहा है एंड दोनों के एप्लीकेशन ऑलमोस्ट सेम है फॉर द सोडियम आयन बैटरीज एंड लिथियम आयन बैटरीज. सो थैंक यू. कुछ क्वेश्चंस है स्टूडेंट्स तो क्वेश्चन पूछ सकते हैं. टाइम थोड़ा सा लिमिटेशन था के बाद, सॉरी मैंने थोड़ा सा फास्ट लिया. इलेक्ट्रोलाइटिक सेल थोड़ा सा डिटेल मैंने एक्सप्लेन किया था, बट एग्जैक्टली अपोजिट इलेक्ट्रोकेमिकल सेल है. सो इलेक्ट्रिसिटी जनरेट करना है हमको, लैबोरेटरी में रिसर्च करना है, तो आपको केमिस्ट्री मालूम होना चाहिए कि कौन सा मेटल का ऑक्सीडेशन पोटेंशियल कितना ज्यादा है और वो ऑक्सीडेशन पोटेंशियल कैसे बढ़ा सकते हैं, रिडक्शन पोटेंशियल कैसे बढ़ा सकते हैं. ये अगर आपको नॉलेज है, उसको आप कंबाइन करेंगे, उसका लाइफ कैसे बढ़ा सकते हैं, बैटरी का लाइफ कैसे बढ़ा सकते हैं, तो इसमें रिसर्च को बहुत स्कोप है. इलेक्ट्रोकेमिस्ट्री को डे टू डेज रिसर्च, 17th सेंचुरी से रिसर्च चल रहा है बैटरी से, डैनियल सेल से. उसके पहले भी रिसर्च था, अभी तक भी उसमें मॉडिफिकेशन हो रहा है एंड एप्लीकेशंस डे बाय डेज उसमें एप्लीकेशंस काफी बढ़ रहे हैं. सो यहाँ बहुत स्कोप है आपको करियर करने का. इलेक्ट्रोकेमिस्ट्री में करियर आप कर सकते हैं. उसके लिए थोड़ा सा आपको इलेक्ट्रोकेमिस्ट्री का नॉलेज, इन डेप्थ नॉलेज आपके पास होना चाहिए. टू द फिंगरप्रिंट आपका सब्जेक्ट नॉलेज होना चाहिए इलेक्ट्रोकेमिस्ट्री का. इवन 2-3 दिन पहले मैंने ऐसा न्यूज पेपर में पढ़ा, रिसर्च न्यूज पेपर में पढ़ा कि ऑर्गेनिक कंपाउंड्स भी इलेक्ट्रोड बनाने के लिए यूज हो रहे हैं. और लिथियम आयन बैटरीज में जो कोबाल्ट एंड लिथियम था उसका रिप्लेसमेंट ऑर्गेनिक क्रिस्टल यूज करके लोग रिसर्च कर रहे हैं. कल परसों ही एक न्यूज में मैंने एक रिसर्च पेपर पढ़ा. सो इसमें बहुत सारा स्कोप है जहां ऑक्सीडेशन इजीली हो सकता है, चीप हो सकता है, और ऑक्सीडेशन से जिससे ज्यादा पोटेंशियल प्रोड्यूस हो सकता है उससे ज्यादा इलेक्ट्रिसिटी आप प्रोड्यूस कर सकते हैं. सो आपको कोई क्वेश्चंस है तो आप मुझे क्वेश्चन पूछ सकते हैं स्टूडेंट्स. एनी क्वेरी? कैन यू हेयर मी? मेरी आवाज आ रही है?
हेलो सर.
हेलो सर. हाँ
ये एक क्वेश्चन है सर.
हाँ
जो
पूछो.
ये सिंगल स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड है,
हाँ
उसके ड्रॉबैक्स भी है.
हाँ
तो रेफरेंस में कौन सा इलेक्ट्रोड जैसे यूजेबल रहेगा?
हाँ देखो, स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड का स्लाइड मैंने बताया था. स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड के काफ़ी लिमिटेशंस है, क्योंकि ये लैबोरेटरी में कंस्ट्रक्ट करना बहुत डिफिकल्ट है. ये लैबोरेटरी में कंस्ट्रक्ट करना बहुत डिफिकल्ट है और उसका कॉस्ट भी ज़्यादा जाता है. एडवांटेज ज़्यादा है क्योंकि स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड अगर प्राइमरी रेफरेंस इलेक्ट्रोड यूज़ करते हैं हम, तो कोई भी दूसरे अननोन इलेक्ट्रोड का ईएमएफ हम पोटेंशियल इजीली मेजर कर सकते हैं। सो जो स्टैंडर्ड कंडीशन है, जो इलेक्ट्रोड्स नियर बाय प्राइमरी रेफरेंस इलेक्ट्रोड के स्टैंडर्ड कंडीशन मेंटेन करेगा, वो इलेक्ट्रोड को हम रेफरेंस इलेक्ट्रोड यूज कर सकते हैं। सो उसके रिप्लेसमेंट हम हाइड्रोजन इलेक्ट्रोड का रिप्लेसमेंट हम सैचुरेटेड कैलेमल इलेक्ट्रोड यूज कर सकते हैं, लेकिन उसका भी स्टैंडर्ड पोटेंशियल एवरी डे चेंज होता है। इट गिव्स अ स्टैंडर्ड इलेक्ट्रोड पोटेंशियल, बट एवरी डे उसका पोटेंशियल आपको जब आप रिसर्च करेंगे तो एवरी टाइम जब आप उसका दूसरे इलेक्ट्रोड का मेजरमेंट करेंगे तो कैलेमल इलेक्ट्रोड का ईएमएफ आपको पहले मेजर करना पड़ता है। सो ये टाइप का प्रैक्टिकल अगर टीवाई के स्टूडेंट है, एमएससी के स्टूडेंट है, तो उनको मालूम है कि आपने प्रैक्टिकल में जब इलेक्ट्रोकेमिस्ट्री के प्रैक्टिकल करते थे तो ई कैल आप मेजर करते थे या कैलकुलेट करते थे बाय यूजिंग अ पोटेशियम हाइड्रोजन थैलेट बफर सॉल्यूशन लेते थे और उसमें क्विन हाइड्रोन पाउडर डाल के क्विन हाइड्रोन इलेक्ट्रोड बनाते थे, दूसरा इलेक्ट्रोड, और ईएमएफ मेजर करके कैलेमल इलेक्ट्रोड का ईएमएफ आप फाइंड आउट करते थे, विच एक्ट्स एज अ सेकेंडरी रेफरेंस इलेक्ट्रोड। सो हाइड्रोजन इलेक्ट्रोड को हम सेकेंडरी रेफरेंस इलेक्ट्रोड कैलेमल इलेक्ट्रोड को रिप्लेस कर सकते हैं। एनी क्वेश्चन?
No, sir. Thank you.
Any another question?
Hello, sir.
हाँ,
If the element has lower electrochemical potential, then there is a more chance of oxidation, right?
yeah, reduction. In the series, the electrode which is in the down in electrochemical series, because series is made from in such a way that they are arranged by decreasing their standard reduction potential. मतलब जिसका इलेक्ट्रोड पोटेंशियल कम है, रिडक्शन पोटेंशियल, उसका ऑक्सीडेशन टेंडेंसी ज्यादा रहता है। तो
Okay, sir.
उससे हम एनोड बना सकते हैं, और जिसका रिडक्शन पोटेंशियल ज्यादा है उससे हम कैथोड बना सकते हैं।
Okay, so in case of Daniel cell, there is a I mean zinc has more tendency of oxidation, right? That's why
Yeah,
it gets eroded.
yeah.
Okay.
It is a natural tendency. So
Okay.
अगर हम देखो जिंक के नीचे वाला इलेक्ट्रोड के साथ हमने जिंक को कनेक्ट किया, मतलब अगर जिंक इलेक्ट्रोड का रिडक्शन पोटेंशियल -0.760 वोल्ट है और उससे कम रिडक्शन पोटेंशियल वाला लिथियम कनेक्ट किया, लिथियम इलेक्ट्रोड, उसका रिडक्शन पोटेंशियल कम है, तो लिथियम का ऑक्सीडेशन होगा और जिंक का रिडक्शन होता है नेचुरली। आर यू गेटिंग?
Okay. Yes, sir. Yes, sir.
हाँ, ओके।
If you apply the battery or power source, then the direction of a reaction gets changed, reverse, right?
रिवर्स रिवर्सिबल रिएक्शन होना चाहिए। जब आप डिस्चार्ज कर रहे हैं तो एक साइड रिएक्शन होगी, तो कंपोनेंट्स कम हो गए, केमिकल कंस्टिट्यूएंट उसके अंदर जो भरे वो कम हो गए, तो उसको फिर से रिचार्ज करना है, अपने केमिकल कंपोजिशन वापस लाना है, तो हमको क्या करना पड़ेगा? इलेक्ट्रोलाइटिक सेल बनाना पड़ेगा, जो पहले पार्ट में मैंने बताया था, या वेयर द इलेक्ट्रिकल एनर्जी इज कन्वर्टेड इनटू केमिकल एनर्जी। सो फिर रिवर्स रिएक्शन होता है, तो केमिकल अपने रिटेन रहते हैं, वापस आ जाते हैं।
Okay, sir. Thank you, sir. And one more thing, sir. Why the in lithium-ion batteries, especially lithium is preferred in most of the batteries? It is because of its lowest electrochemical potential, right?
Yeah, it has a since lithium is a most electropositive metal means it has a greater highest oxidation potential tendency. That series I had showed you, that it is in the last in the series, less reduction potential but highest oxidation potential. So उससे इलेक्ट्रिसिटी हमको ज्यादा मिलती लिथियम से।
Okay, sir. Thank you, sir.
Thank you so much, sir,
Yeah.
for your enlightening, sharing your valuable insights have provided with us. and deeper understanding of electrochemistry. And we are truly appreciate the time knowledge you have shared with us.
Okay, thank
Now,
you.
uh, conclude the session, I would like to invite Professor Misbah, Assistant Professor in Chemistry Department, to deliver vote of thanks. Please, Professor Misbah, ma'am, take over.
Hello,
हाँ,
Honorable Principal Dr. Iguana Hamdani, Vice Principal Dr. Arif Anjum, IPSC Coordinator Dr. Shakib Ahmed, Respected Academic Head Professor Imran Ahmed, Head of Department Professor Rahmani Mudassir, Honorable Chief Guest of today's webinar Dr. Kailash M. Dokim, esteemed faculty members and participants. I am Professor Misbah. It's my privilege to present vote of thanks on behalf of organizing committee. I would like to extend our heartfelt gratitude to each and every one of you for making this national webinar on fundamentals of electrochemistry a resounding success. We are deeply grateful to our keynote speaker for sharing their invaluable insights and expertise with us. Your presentation were enlightening, informative, and thought-provoking, and we appreciate the time and effort you took to prepare and deliver them. We are also grateful to our organizing committee members, technical team, and who worked behind the scenes to ensure the smooth execution of this webinar. Once again, thank you all for your contribution, participation, and support. Thank you. Thank you so much. The webinar is officially ended here.
thank you.
Thank you.